So this is a video on rotations, which come right after reflections in the transformations unit in applied geometry. Rotations are when the entire coordinate plane is going to spin around the origin. So we're going to take points and spin them around the origin and see where they end up. To graph a point, there's a very specific pattern we're going to follow. We're going to start with this point 5, 3. We're going to do an example as I explain this, and there will be several more examples after this. So, to rotate a point, we want to graph the original first. So we're going to go ahead and graph this point 5, 3. So we go forward 5, up 3, and we have our point right here. We're going to then rotate our whole paper. In this case, we're just going to do 90 degrees, so we're going to rotate it a quarter spin. So it spins like this. We want to write down the new coordinates. So this point is no longer at 5, 3 because we're looking at our paper in a different way. So from the origin, we're going backwards 1, 2, 3, and we're going up 1, 2, 3, 4, 5. So our new coordinates for this point are actually -3, +5. So we're going to write that down. -3, +5. We're going to spin our paper back now to how it was originally. So we take it and spin it back. So our point is back where it started. And now we're just going to graph this new set of coordinates we have here. We're going to regraph these coordinates. So we're going to go to -3, +5, which is right up here. And that is where our new point would be. So if this was A, the new one would be A prime. And that's taking and spinning this whole thing around. So I'll give you 10 seconds to go ahead and copy that. All right. There's a rule for rotations of 90, 180, and 270. We're going to go through one example of 90, one of 180, and one of 270. Unless otherwise noted, rotations are always going counterclockwise. So we're going against the way the clock moves. We're actually spinning to the left. Okay? So we're going to start with triangle XYZ, and we're going to rotate it 90 degrees. So our first point is going to be X, which is 1, -2, so forward 1, down 2. Y, which is going to be 5, -6, which will be right down here. And Z, which is 5, -1, so right over here. And we'll go ahead and connect those right up. All right. So we're going to spin 90 degrees now, and it's 90 degrees counterclockwise. So we're going to take this whole grid, and we're going to go ahead and spin it 90 degrees, like so. And we need to write down the coordinates now of X, Y, and Z. That's why it's super important that you're labeling. So I have X, Y, and Z labeled here. So starting with X, we can see that our new point is at 2, 1. So X prime is going to be at 2, +1. Y is up here, and we go forward 1, 2, 3, 4, 5, 6. So we went forward 6, and we're going up 1, 2, 3, 4, 5. So our new point should be at +6, +5. And our last one, Z over here, is at +1, and then we went up 1, 2, 3, 4, 5. So we're at +1, +5. So we'll write that down right over here, just like we did the rest of them. Okay, we're going to take now and spin this whole paper back so we're looking at it straight again. So it spins back to here. And the last part is just regraph these 3 points. So we're going to have 2, 1. So we go forward 2, up 1. And we're going to label that X prime. We have 6, 5, which is going to be Y prime. So we go forward 6 and up 5, which is right here. We're going to label that Y prime. And Z prime is going to be at +1, +5, so right here. And we're going to label that Z prime. Okay, make sure you're being very careful when you graph these in your notes that you have them correct. Make sure you count the number of spaces and get them all on there correctly. I'm going to give you some time to copy this down, and I also want you to look at this here. Look at what happened from X to X prime, Y to Y prime, Z to Z prime, and see if you can figure out the rule. All right, so hopefully you have that all written down, and now we're going to discuss the rule. So if you look, x was at 1, negative 2, and x prime is at 2, 1. Y was at 5, negative 6, and y prime is at 6, 5. And z is at 5, negative 1, but z prime is 1, 5. So something's happening here. First of all, you'll notice that this is a 1 and a 2, this is a 2 and a 1. 5 and 6, 6 and 5, 5 and 1, 1 and 5. So they're actually going to switch places, and that second value is going to switch from positive to negative or negative to positive, depending on what value it is. So the rule for 90-degree rotations is that whatever your x and your y are, so your x and your y, they're going to switch places, and the y becomes negative out in front here. So if it was already negative, it would turn to positive. So go ahead and write that down. xy turns into negative yx. So without doing this whole thing, you could tell that x goes from negative or positive 1, negative 2 to 2, positive 1. Our next one is going to be a rotation of triangle ABC 180 degrees now. So we're going to spin halfway around. So we're going to start with our points, which are A, 2, 1, right here. B, which is 5, 2, right here. And C, which is 1, 5, right up here. And notice I labeled them all, A, B, and C's bouncing in here. And then you can go ahead and connect them. Okay? We're spinning those 180 degrees. So we're going to take this and spin it all the way down, so it should end up somewhere down here. Spin it all the way around. And now we're going to rewrite those coordinates. So A is now at negative 2, negative 1. B is at negative 5, negative 1. Sorry, negative 5, negative 2, I apologize. And C is at negative 1, negative 5. Okay? We're going to take this and spin it all the way back around, so we're looking at it straight again. And we're going to regraph these 3 points. So A prime is at negative 2, negative 1. B prime is at negative 5, negative 2. And C prime is at negative 1, negative 5, right down here. And we can go ahead and connect those up. And again, I'm going to give you some time to write this down now, and I'd also like you to look here and see if you can figure out what happens when you go from A to A prime, B to B prime, C to C prime. So what is the rule for a 180-degree rotation? Okay, so we're going to be looking at a rule here. So the rule for 180-degree rotations. Again, we're going to start with whatever our values were for x and for y. And now, if you look, this is 2, 1, and it goes to negative 2, negative 1. This is 5, 2, and it goes to negative 5, negative 2. So, to generalize that rule, whatever you start with, whatever point you have here, is just going to turn into a negative x and a negative y value. And again, if you started with negative numbers, they would turn positive over here. Okay, so the sign just changes for a 180-degree rotation. The last one we're going to do here is triangle LMN, and we're going to rotate it a whole 270 degrees. It's a really far rotation. It's 3/4 of the way around. So we're going to start with our 3 points, which are L, 2, 5, right up there. M, which is 6, 4, right over here. And N, which is 3, 1, right over here. Go ahead and connect those up. And we're going to rotate it 270 degrees now. So we're going to spin it all the way around. Well, almost all the way around. 3/4 of the way. So we're going to go ahead and spin that. And you'll notice that, again, our letters aren't facing the right way anymore. But we want to write down what our coordinates would be looking at the paper like this. So L goes to a 1, 2, 3, 4, 5, 6, negative 2. M is going to go to a 4, negative 6. And N is going to go to a 1, negative 3. Okay. We're going to take and spin this back around. So it's face up again. If you spun the other way, it's fine. It's not a big deal. You're just looking at the paper straight on again, so it's the right way. And you're going to go ahead and graph those points. And this is actually, should be a 6 in here. This should not be a 5. It should be a 6.
Let's play some Tetris,
And,
motherfucker.
oh, song changing. And this should be a 6 also here. Okay. So we'll go ahead and graph those. We have L, which is at positive 6, negative 2. M, which is at positive 4, negative 6. And N, which is at positive 1, negative 3. Should be an N also. So there is a rule for this as well. I'm going to go ahead and give you some time to copy this down and look at these coordinates here. Remember, these are 6s. And see if you can figure out what the rule is. Alright, so looking at this rule here, we're looking for a rule for a 270-degree rotation. We go from 2, 6 to 6, negative 2. We go from 6, 4 to 4, negative 6. And we go from 3, 1 to 1, negative 3. So we're starting with our x and our y values. And again, you'll notice the 2 and the 6 switch places. The 6 and the 4 switch places. The 3 and the 1 switch places. So we're going to switch their places. And that second one is going to switch its sign. So it's going to go from xy to y, negative x. As you can see up at the top here, this is not in the notes, so you need to write it down. You'll need to add 3 separate lines here. I'm just going to show you a quick counterclockwise rotation versus a clockwise rotation. So, a counterclockwise rotation of 90 degrees is the same as rotating clockwise 270. So turning this one back 1/4 and turning this one forward 3/4 is going to get you to the same place. So you can kind of watch these right here. They're both going to spin. So we spun this one 1/4 of the way to the left. We spun this one 3/4 of the way to the right, and they end up in the same place. The second thing that you need to write down is that a counterclockwise rotation of 180 degrees is the same as a clockwise rotation of 180 degrees. So if we spin this one halfway to the left and spin this one halfway to the right, they're going to end up to be the same. So both these triangles end up looking identical. And the last thing that you're going to need to write is that a counterclockwise rotation of 270 and a clockwise rotation of 90 is going to get you the same place. So this one going to the left 3/4 of the way and this one going to the right 1/4 of the way end up in the same place. So a counterclockwise rotation 270 is the same as a clockwise rotation of 90 degrees. So go ahead and watch these again. So this one spun all the way around to here. This one just spun 1/4 of the way, and they end up to be the same. So I'll give you a second to copy that down. That is the end of the notes. If you did not have time to write all 3 of those statements down somewhere in your notes packet, you should rewind and make sure you get all of them.